Hello everyone. So in this segment we are going to see a contrapositive of a conditional statement. A conditional statement is a statement where we see this format P implies Q. So it means that if P implies Q, it means that if P then Q. So if P is true then Q is true. Now the contrapositive of a conditional statement P implies Q is not Q implies not P, and you can see that they are logically equivalent. So this is the contrapositive of P implies Q. Alright, and these two statements are logically equivalent. So we can use this symbol or we can also use this symbol to show that they are logically equivalent. So one way to prove that two statements are logically equivalent by using a truth table. Okay, so let's just quickly see the truth table of both two statements. So if we have P implies Q, we know that like the truth table looks like true, 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 false. So true, true is true. All right. True, false is false. And these two statements, as P is false, we do not know what happens if P is false. So we consider them true. All right. Now let's see the truth table for Q implies. Okay, so here let's see the truth table for not Q implies not P. Okay, this one. All right, so let's see not P not Q. We are going to have here false, false. We are actually translating it from here false, false, true, true, and it will be false, true, false, true. So not Q implies not P. This is going to be true, false. Sorry, true, true, it will be true. All right, true, false will be false. Now wherever we have false for Q, it is going to be true. So you can see that the truth table is exactly same. All right, for the same combination we found the truth table is exactly same for P implies Q or not Q implies not P. So they are logically equivalent. We can show them using the truth table, and also this statement is known as a contrapositive of a conditional statement. So let's see some English example to prove that a contrapositive of a statement is logically equivalent to the same statement. So a conditional statement P implies Q. Let's see a English example. Let's say we are using an example like that. If I study hard, then I will pass. So let's say this one is my statement P, and then I will pass. This is my statement Q. So P is a statement that I study hard, I will pass. That's the statement of Q. All right. So if I study hard, then I will pass. So P implies Q. That's actually that has another logically a logically equivalent statement, which looks like not P or Q. Okay, so P implies Q is logically equivalent to another statement like not P implies not P or Q. So let's see example. Let's see, we write not P, okay, or Q. So I didn't study hard. That's my not P. Okay, I pass. That's my Q. All right, and now let's connect them using or. So that means either I didn't study hard or I pass. All right, so either I didn't study hard or I pass. This is equivalent to the statement not P or Q, and you can see that they are actually same. They're actually logically equivalent. You can also test them using a truth table. Okay, so P implies Q is logically equivalent to not P or Q. So you can see that if I study hard, then I will pass. This is P implies Q. Either I didn't study hard, which is not P, or or I pass, or Q. This is the same English sentence. This is the same English sentence. They both means the same. Okay. All right. So we can see that P implies Q is equivalent, logically equivalent with not P or Q. So P implies Q is logically equivalent with not P or Q. Now let's look at this example, this statement. Nor Q implies not P is going to be equivalent to not Q or Q or not P. Okay, so not Q or not P. So P implies Q is logically equivalent with not P or Q. So this is going to be equivalent with not Q or not P. Okay. So which is same as Q or not P. All right, and same as, I mean, we know the rule that if we just interchange them, not P or Q, this means the same. So you can see that P implies Q is logically equivalent with not P or Q, and this is also logically equivalent with not P or Q. So that means they are logically equivalent. So let's just see another English example which using the same example, and you will find that they means actually same. So P means P means I study hard, or Q means I will pass. Okay, so not Q implies not P. If we translate it like this, it is going to be look like not Q means I don't pass. Okay, and not P means I didn't study hard. I didn't study hard. So if I don't pass, okay, if I don't pass, then I didn't study hard. So that is my not Q implies not P. If I don't pass, then it means I didn't study hard. So that means not Q implies not P, and they means actually the same. If I study hard, that means I will pass. If I didn't pass, that means actually I didn't study hard. Okay. All right, so that means they both are actually the same. Using the English word, they, you can see that they means all of them they means the same. Okay, so they all are P implies Q, not P or Q, and not Q implies not P. They all are logically equivalent statement. All right, now just remember that P implies Q is not same as Q implies P. All right, P implies Q is not same as Q implies P, but P implies Q is same as not Q implies not P. Q implies P is going to mean that um, if I pass, that means I studied hard. It doesn't actually mean that. Okay, so this is not actually same. If I pass, there could be lot other reason that I have passed. Okay, but this statement says that if I study hard, then I will pass. Now if I don't pass, there is a reason that I didn't study hard. Okay, but if I pass, then it doesn't necessarily mean that I have studied hard. Okay, so they are not same, but P implies Q means that not Q implies not P. Okay, and they are logically equivalent. The converse of statement P implies Q is the statement Q implies P. So this is actually known as the converse of the statement. So P implies Q means if P then Q. The converse means that if Q then P. So remember that P implies Q and Q implies P. They are not logically equivalent. Okay, means they are not logically equivalent. It's very important to remember. All right, so you can try it using truth table, or let's use few English sentence first to see how they are not logically equivalent. So let's use a example for P implies Q first. So let's see, P means it's a dog and Q means it's a mammal. Okay, so it's a dog, it means P, and it's a mammal, it means Q. So if it's a dog, then obviously it's a mammal. Every dog is a mammal. Okay, so that this is true. P implies Q is true. If it's a dog, obviously it will be a mammal. Now what about if we converse the statement? Let's make Q implies P. So if it's a mammal, then it's a dog. Is it true? This is our Q, this is our P. Now do you think it's true? No, that's not true, because if it's a mammal, it could be actually anything. It could be a dog, it could be a cat, all right, it could be any other animal. There are a lot of it could be any other animal, but mammal animal. But if it's a mammal, it's not necessary then it has to be a dog. Okay, so that's not true. So the converse of a statement is not actually logically equivalent. All right, and you can try it by looking at the truth table also. So P Q, P implies Q will be okay, so it will be true, false, true, true. Now what about Q implies P? Okay, so true, true will be true. Okay, so these two false, where the Q is false, they will be also true, and true false will be false. And you can see that the truth table is not same. So we can say that they are not logically equivalent. So the gist of this discussion is converse of a statement is not logically equivalent to that statement. The inverse of a statement of conditional statement is statement P implies Q is not P implies not Q. So the inverse of a statement P implies Q is not P implies not Q. Okay. Now I want to think you about just for a minute, just for a second, to think about whether just try to figure out that whether they are logically equivalent or not. Okay, so first you can find out using the truth table. Okay, using the truth table you can easily find out whether these two statements are logically equivalent or not. All right, then we are going to use some English sentence to prove that whether they are logically equivalent or not. So let's see, P Q, P implies Q. All right, so true, false, false, true, false, false. So this will be true, 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 false. All right, and not P implies not Q. What about that? So not P implies not Q. It will be actually we are going to write that here. So false, false, true, true, and false, true, false, true. So not P implies not Q. It will be true, true. It is going to be true. It will be false. It will be true. It will be true. Okay, true, false, true, true. With yeah, we are using the same combination of PQ. So we found the truth table. True, false, true, 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 false, true. It's not same. Okay, so they are not same, so we can see that they are not logically equivalent. All right, so let's see, just try to again verify with a plain English statement. Okay, let's use the same example. If it's a dog, it's a mammal. All right, so it's a P and it's a Q. Now let's write the statement not P, then not P implies not Q. If it's not a dog, then it's not a mammal. What do you think? It's not P and it's not Q. Do you think it's true? No. If it's not a dog, that doesn't necessarily mean that it's not a mammal. It can be a cat. A cat is a mammal. If it's not a dog, it can be a cat. So if it's a cat, it can be a mammal. So if it's not a dog, it's not necessarily mean that it's not a mammal. So that's not true. Okay, so that means P implies Q is not same logical equivalent with not P implies not Q. Okay, so for this lecture we are going to see the last thing about the last statement here, last example here. So we are going to see the negation of a conditional statement. So the conditional statement or implication P implies Q means that if P, then Q is true. If P, then Q. All right. Now if we negate a conditional statement like not P implies Q. Okay, so it is going to be same as logical equivalent with P and not Q. Okay, P and not Q. So how we can actually show them, how we can prove that? We know that P implies Q is same as logical equivalent with not P or Q. Okay, P implies Q is logical equivalent with the statement not P or Q. We actually see that in this example, that P implies Q is same as logical equivalent with not P or Q. Okay, now let's negate both of them. So not P implies Q. Okay, and let's negate this one. All right, so here what we can do, we can actually use a De Morgan's law. Remember De Morgan's law? So if we let's show you, the De Morgan's law is this one. Not P or Q is same as not P and not Q. Okay, or not P and Q is logically equivalent with not P or not Q. So we can actually distribute the negation operation for both, but this symbol is going to change. This symbol is going to change to and to or to and. So this will be same as logically equivalent with not P. Okay, and this will change to and not Q. Okay, so this is same as this will be P and not Q. Okay, P and not Q. So and they are logically equivalent. All right, so again I'm saying you can use both symbol to show that they are logically equivalent. All right, so the negation of a conditional statement of P implies Q, negation of P implies Q is logically equivalent to the statement P and not Q. All right, so for now that's actually all of our example of statement. So in the next segment we are going to see actually argument. Okay, and we will see given a argument we are going to prove that whether a argument is valid or not.